Okay, we start with the implement of the p-median algorithm in MATLAB. Remember, the arguments for the program should be the distance matrix M and the number of the cells required P. The distance matrix we see here, it had six it has 6 rows and 6 columns, and the solutions should be this. Okay, goes to the program, and we start with some commands to clear some variables that the program saved in the case that we run the program again, and it used to the program don't show grow results. Okay, introduce the number of the cells. Remember that P are the number of the cells that we need. In this case, the program showed the message introduce the number of the cells that we need. M introduce the dimension of the distance matrix. In this case, the dimension of the distance matrix is six rows and 6 columns. A is the distance matrix, but we use this line to create a matrix with zeros that have the dimensions of the distance matrix. Okay, we start here with an iteration that use the sentence for I equal 1 to 6. Remember that M has the value 6. And in the same way, for J equal 1 to 6. The program showed the message, the value of the distance in first row and first column. In this case, this number is 0. Later, repeat the iteration with the message, the distance value in the first row but second column. In this case, this number is 6. All of these numbers in the same way. Here we have here the complete distance matrix, and then we start create some vectors and matrix to save some variables that we find. The vector T have the dimensions 1 row and 6 columns, and we use this vector to save the results in the summatory of each column. Then we create the matrix F, that is a matrix with zeros that have the dimensions 2 rows and 1 column, to save the number of sequence. Later we have the matrix Z, that is a matrix of zeros that have 2 rows and 1 column. And later, in the same way, we have the matrix and the vector FA and T1 to save the variables of the machines that goes to one seed point. We will use these variables later. Continue with the explanation. We start with a big iteration with the sentence for k equal 1 to p. Remember that p is the number of the groups that we need. In the case that the number of the groups is 1, the program enters the sentence if and do for I equal 1 to m. M is the dimension of the distance matrix. Do the summatory of each column of the distance matrix and save these values in the vector T, iteration I. And the sentence for and find the minimum value in the vector T and save these values in the matrix C and F iteration K. The program finally shows the message with these results: distance Z with a first seed point, with a second seed point, or with a third seed point, and shows the results in matrix F iteration K with the message the seed point is. Break the sentence for and end the iteration with the sentence if. In the case that the number of the groups don't be 1, the number of the groups, the iteration that the program do is in the same way: a summatory of each column, find the minimum value in the vector T and save these values in matrix C and K, C and F in the iteration K, and we have another iteration to minimize all the values in the row that have the same value of the column that have the minimum distance value. For example, in the iteration that we found the summatory of the minimum distance value, we have the summatory of the first column is 21. We have the summatory of the third column is 21, and we have the summatory of the fourth column is 21 too. Then the program selects the first column to eliminate the first row, turn all the values 0, and then in this iteration the program takes the columns that have the same minimum distance value of the seed point select and turns the row with the same value, third column, third row, fourth column, fourth row, and turns all these values in 1. In this case, because 1 is the minimum value in the third row and in the fourth row. Then, third row, first column, 1. Third row, second column, 5, turns 1. Third row, third column, don't change, the value is 0. Third row, fourth column, 2 turns 1. Third row, 5 column, 8 turns 1. Third row, 6 column, 5 turns 1. In the same way with the row number 4. And this iteration for the rows and the columns and the sentence 4, and in the same way of the last part of the program shows the results that we have in the matrix C iteration K and matrix F iteration K, and then end the biggest iteration. Finally, we have to form the groups with the rest of the machines that don't be a seed point. For this, we have 2 iterations. In the first iteration, we use the matrix FA, and in the last iteration, we have the vector T1 that we explained in the first part of the video. In the first iteration with the sentence for j equal 1 to length f, remember the matrix F have the dimensions 2 rows and 1 column, and the matrix FA, all the rows and the first column, in this case iteration j, equal to a, all the rows and the column that we select have a seed point. And the first sentence for and start the second iteration, k equal 1 to length f, fa minimum value change with the term none. We use this line to omit the the number 0 in the moment that we select the minimum value of the term of the vector t1. Then another sentence for I equal 1 to length fa, do the summatory of the first column, the first row, all the columns, in this case iteration j, and save these variables in the save these results in the variable t1. And the sentence 4, and in the next step we use the variable b to find the minimum value that we have in the vector t1, but omit none. In this line we say that the locations that we find the minimum value of vector t1 are 0. We use this line to transform the location of the machines that we have the minimum distance in 0 for the next iteration. For example, the solution should be that the C.1 have the machines 3 and 4. We need that this position 3 and this position 4 turn 0 in the next iteration to don't consider these values in the iteration that the seed point is 5 and the machines are 2 and 6. Finally, fprintf, the program shows the message, the machines in the seed point. The results of the seed point are here. F in the iteration k, R in this case the machines, each group have 2 machines, 2 variables. But for example, in this case p equal 2, we have each seed point have 2 machines. But in the case that p equal 3, we have 3 seed points. Seed point 1 has the machine 3 and 4. Seed point 5 has the machine 6, and seed point 2 don't have machines. In the case that we run the program with p equal 3, the message that the program shows here say the machine in the seed point 2 equal and an empty space because the seed point 2 don't have machines. And finally we end all the program and then run this. Okay, the first message that the program shows say introduce the number of the groups that we need, in this case 2. Introduce the dimension of the distance matrix. The matrix have 6 rows and 6 columns, 6. The distance value in first row and first column is 0. The distance value in the first row and second column 6. 1, 1, 7, 6, 6, 0, 5, 5, 3, 4, 1, 5, 0, 2, 8, 5, 1, 5, 2, 0, 6, 7, 7, 3, 8, 6, 0, 3, 6, 4, 5, 7, 3, and 0. Okay, and the results are the distance matrix here and the message. Distance z with 1 z point is 21. The seed point is 1 for the first iteration. And the distance z with 2 seed point is 8. The seed point 5 for the second iteration. Here we have the seed point the seed points are 1 and 5, and the distance is 8. We check with the solution, and we have the distance 8 and the seed point 1 and 5. And for the groups, we have the machine in the seed point 1. The machines in the seed point 1 are 3 and 4. The solution 3, 1 and 4, 1. And finally, the machines in the seed point 5 are 2 and 6. Seed point 5, 2 and 6.